And so with that introduction, I want to come back to the model that was introduced earlier. This is basically a multiplex model where AkaLuc was introduced into T cells. And this is the model that Andrew explained, where there was one set of mice that were injected with T cells that recognized the tumor antigen and one set of T cells that didn't. Each of them were transfected with AkaLuc. The tumor was created expressing Antares, so it constitutively expressed Antares within the tumor. And then once the tumor had been established and the T cells injected in the mice, the two substrates were injected sequentially. So fluorofurimazine was injected on one day. The signal purely from the tumor was measured. And because fluorofurimazine does not interact with firefly luciferases at all, there was no signal from the T cells. The next day, AkaLumine was injected, and because again you have complete orthogonality, only the T cells gave a signal with the AkaLumine injection from the AkaLuc, and no signal came from the tumor cells. The signal coming from the tumor was all due to T cell infiltration. And so here's an example of that sequential injection. So on day 17, FFZ was injected and the tumor lights up brightly. On day 18, you can see the T cells still have not established well, so you get a fairly diffuse and non-bright signal. Then on day 29, with the T cells that are responsive to the tumor, you can see that on FFZ injection, you get a very faint signal. This is due to the tumor having been mostly eradicated. But you see that the T cells are still quite present, and you see quite a bright signal from the AkaLuc AkaLumine system showing the T cells still at the site where the tumor is being eradicated.